Chapter 18, Water Pollution. As we learned in previous chapters, water is essential to life. We also discussed that water is a renewable resource. However, it can be converted to a non-renewable resource by pollution. This chapter discusses current issues with water pollution and how we are working to address it. Water pollution is any physical, biological, or chemical change in the quality of water that causes a negative impact on living things. This makes water unsuitable for use and potentially non-renewable. Sources of pollution are either point, easily identified, discharged from a specific point, or non-point, hard to identify the source, no single discharge location. Non-point sources of pollution can occur by many means. One such source is the atmosphere. Contaminants released into the air are picked up by rain and snow and deposited on the land. Because we don't know the exact source of the pollution, it is very difficult to regulate or control the water pollution from the atmosphere. Aquatic organisms require dissolved oxygen for respiration. However, the decomposition of organic materials in water also require oxygen. The bacteria that decompose the organic matter require oxygen. We have ways to measure how much oxygen each required. The most important is the BOD, or biochemical oxygen demand. This is the amount of oxygen needed by the bacteria during decomposition. By comparing this to dissolved oxygen content in the water, we can estimate the burden of organic matter introduced into surface waters. If the source of the organic matter is a point source, we often see a reduction in the O2 content downstream of the source. This is called an oxygen sag. An illustration of oxygen sag. Note how oxygen levels decline downstream from a pollution source as decomposers metabolize waste materials. Another source of pollution in surface waters are plant nutrients. These can be in the form of fertilizers or human and animal waste. These add nutrients to the water, increasing the productivity. The addition of nutrients is called eutrophication. Typically, we are most concerned with phosphorus in freshwater and nitrogen in oceans. If the addition is due to human activities, it is cultural eutrophication. Regardless, the consequence of increased nutrients is an increase in algal production, which often leads to decomposition as they die. One serious consequence of eutrophication are toxic tides. These tides are caused by a dinoflagellate that is red in color. The dinoflagellate releases a compound that can act as a neurotoxin, which, if ingested, can actually kill fish and mammals. Because the dinoflagellates are red, they make the water red, hence the name red tide. Pollutants do not have to be organic. They can also be inorganic. These inorganic pollutants can be metals and non-metallic salts. Of most concern are the heavy metals such as mercury, which can bioaccumulate to levels that are toxic. These come from atmospheric sources, mine waste, and industrial sources. Non-metallic salts often contain toxins such as arsenic and selenium. Even basic road salt has been shown to impact streams and the aquatic organisms that live there. Other metal contaminants in water. Mine drainage and leaching of mine waste are serious sources of environmental contamination. In a Tennessee study, 43% of streams and 50% of groundwater contaminated by metals and acids from mine drainage. Inorganic pollutants, non-metal salts. Many salts, including those selenium and arsenic-based, that are non-toxic at low concentrations, can be mobilized by irrigation and concentrated by evaporation, reaching levels toxic to plants and animals. Leaching of road salts has had detrimental effect on many ecosystems. Arsenic in northeastern India and western Bangladesh groundwater. The largest water pollutant by volume is sediment. Sediment covers breeding habitat and fills in slow-moving bottles of water. The primary source of sediment comes from agriculture. However, construction and building also contribute. This is why most cities have ordinances that require sediment be controlled during construction projects. One final pollutant we need to discuss is thermal pollution. Most people don't realize the effects an increase in temperature can have on the health of a body of water. One main effect is the level of dissolved oxygen. As temperatures increase, the solubility of oxygen decreases. In other words, warm water holds less oxygen than cooler water. As mentioned earlier, a decrease in oxygen can cause fish and other aquatic organisms to die. The primary source of thermal pollution are industry and power plants. Both need a lot of water to regulate head within their respective industries. Industrial cooling processes often use heat exchangers to extract excess heat and then discharge heated water back into original source as a thermal plume. Disrupts natural ecosystems. Cooling ponds or towers are required to reduce thermal pollution. It was quickly realized that water is important for life. U.S. legislation has been passed to protect our water resources to include improving their quality. The Clean Water Act was passed in 1972 to establish standards for water and to require permitting for dumping. It also set goals for improving water quality. Since the passage of the CWA, the approach to protecting our waters has changed. Where the EPA used to regulate on a site-by-site basis, they now regulate based on a watershed level. A watershed is simply the total area that collects water that drains into a specific river or stream. States are now required to report violations if they exceed a total daily maximum load for the watershed. Another area of success has been the regulation of human waste. Human waste is high in not only bacteria, but in plant nutrients such as phosphorus and nitrogen. Untreated human waste will rapidly cause eutrophication of a body of water. Advances in treatment include better technology for septic systems in rural areas and municipal systems in urban areas. An illustration of a septic tank. Municipal treatment systems are point sources systems, so they are easy to monitor and regulate. These systems are categorized based on the level of treatment on the effluent. The levels are primary, secondary, and tertiary. A municipal wastewater treatment facility is categorized by the highest level of treatment they conduct. For example, if a system only removes the large solids from the effluent, it is a primary system. If the system removes the solids and the dissolved organics before disinfection and release occurs, it is a secondary treatment facility. Note that a secondary facility conducts primary and secondary treatment. A tertiary system does both primary and secondary treatment, but it also uses either chemical or biological processes to remove plant nutrients. Most use a chemical process because the results are better, but it is also more expensive. What kind of system does your local city have? Photos of a municipal sewage treatment.